Okay, students, welcome back. It is another Thursday, and we are here for STEM in our community. Okay, so here we are for another Thursday, STEM in our community, and we are visiting the West Virginia Air National Guard's firefighting department, and we are talking to Sergeant Fry. So Sergeant Fry, what is your job here?
Hi guys, I'm a firefighter with the 167th Air National Guard here at Shepherd Field in Martinsburg. I'm also the training representative for our shift, the shift lieutenant, a fire instructor, a fire inspector, a wildland firefighter, blah, 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 blah. We could do this all day. So basically we have a lot of different jobs. There's no such thing as just a firefighter here.
And one of the things we like to do is we like to focus on the science and the technology involved in the jobs around our community. So looking through this firehouse, we see a lot of really nice equipment, a lot of fancy equipment, even down to the uniforms or the equipment you wear. So how does the science involved in firefighting?
Well, I'll start with basically what I'm wearing right now. This is a little bit different than the uniform that everybody else wears on base. This is actually a flight crew uniform, so it's already treated with a fire retardant, and it's 100% cotton, so it takes a lot more heat to get this thing going. The boots, steel-toed boots and zippered on the side so they can be removed quickly if we have to use them in an emergency. Did you want to talk about the gear next?
Let's talk about the gear.
Sure. Can I get a volunteer from the audience here? All right. The first thing we're going to talk about is a standard piece of structure gear. It's your firefighting coat. You'll see it looks a little different on the inside. It does have two layers. It has a thermal barrier inside that protects you against heat, because we all know in science the first thing that happens to water when it gets heated is it starts to boil, right? That lets off steam, turns you into all kinds of interesting things on the inside. So this actually protects you against that steam conversion or that transfer. The exterior is woven Kevlar. I don't know if you can see the pattern up close, but basically these are strands of fiber that provides puncture protection, fall protection, limited heat protection, but mostly it's against abrasions and cuts, because when a building collapses, obviously the materials turn into very different things. So I'm going to go ahead and put this on our volunteer here. I'll let her zip or Velcro the front if she'd want to. That fits you perfectly. Now, everybody always asks what these are. If her little T-Rex arms would fit through there, I'd show you what they are, but oh, there you are. All right, hi. I don't have fingernails like yours, but this thumblet right here basically makes sure that none of her skin is exposed on the wrist or anything like that that could be damaged by heat or fire or anything else inside. Now the gloves would then go over top, so it provides full coverage. Same way with the neck. You'll see this piece would wrap around the neck. Just right there. Just wraps around the neck right there, so when you put your mask and your hood on, covers up your neck, the back of your neck. No pieces of skin exposed, because we go into temperatures up to 800 degrees or more. Next, you have your typical helmet. Basically, this is just impact protection. The shields are kind of a tradition. They do sit a little high, but the helmet itself is designed so that everything that hits you would fall away. You see the spine on top and the low brim down here. Anything that hits you would basically fall away from you. I don't have the problem messing up hair, so I apologize if this messes up your hair. But basically anything that hit her would be directed away from her body, because sometimes we have to use the helmet itself as a tool to punch through drywall, things like that. So we want as much protection as humanly possible.
Okay, so you have a jacket. The material you said was Kevlar?
Yes, sir.
So that's basically the same material that's in bulletproof vests.
Helmets, ballistic vests, yes, sir.
And then you have your helmet to protect you from falling objects. What about the face?
I think her face is fine.
Okay.
Okay. Oh, protecting her. Okay. All right. Well, the first thing you'd have are these flip-down goggles. If you were doing a vehicle extrication or going somewhere where eye protection was necessary, it's already built in. As far as being able to, I apologize if I pull your hair again, that's not my concern. When she goes into a oxygen deficient or a fire environment, she's going to be wearing an SCBA face mask. This would be in two pieces because it is positive pressure. So her mask, and this person obviously wears glasses, so there's the inserts. The mask would cover her face fully, wear around the bottom of the chin. She'd also have a Nomex hood on that would protect the back of her head and her neck. It would then wrap around this, again creating that seal so there's no exposed skin. The positive pressure SCBA portion would be connected to the cylinder, so it has 4,500 pounds of compressed air. And once this is clicked in, when she takes a breath, it automatically starts the positive pressure system and allows her to breathe compressed air.
Now you said SCBA.
Self-contained breathing apparatus.
Now if you add one more letter to that, it might be something that students are more familiar with.
Scuba tanks, exactly right.
SCUBA.
SCUBA. The only difference between what we do and what they do is they do it underwater, and hopefully there aren't any fires there, because I wouldn't know the first thing about putting that out.
Okay.
Underwater fires would be very scary. I don't think I want to play that.
If the fire burns underwater, then you're in trouble.
None of these trucks float.
Yeah, because let's talk about different types of firefighting
Sure.
materials, because water is not, they all go to when you're trying to put out a fire.
Absolutely not.
So what is the fire structure? What are the 4 things that a fire needs in order to live?
Okay, the fire tetrahedron composed of fuel, heat, oxygen, and a self-sustaining chemical reaction.
So when you're putting out a fire, you're trying to take away at least one of those things. Right?
One, if not more, exactly right.
So why not always water?
Well, believe it or not, water can actually make a lot of fires worse. And the example I like to give a lot of people is bacon grease. Everybody typically likes to make something on the oven, and sometimes it gets greasy. If there were ever to be a fire, the last thing you'd want to do would be to throw water on it, because that's a liquid on a liquid. It's going to spread it out farther. And because they don't mix, it's not going to reduce the heat. It's not going to do anything to stop that fire. It's simply going to allow it to spread further. So an example of that would be to smother it with the top of a pan or a skillet lid or a wet towel. Then you're smothering it. So the approach we have to different types of fires depends on what's burning, how it's burning, and where it's burning.
So when you're reporting to a fire, it's not just let's go put the fire out. You have to know what is causing the fire.
I wish it was that easy. We could just sit in the truck, enjoy the ride, watch the traffic part, and we could just show up and spray water on it and leave.
Right. And based on that, you have a lot of equipment throughout the firehouse for different types of fire.
Yes, sir.
From the trucks, there's different types of equipment as far as the trucks, and you also have different types of equipment as far as the handheld equipment that you use. So what are some of the handheld equipment?
Well, with the rescue engine open right here, I'll show you this vehicle. This one is your standard pumper. Most people are going to see this kind of fire truck almost anywhere throughout their neighborhoods. It's a 500-gallon water tank. You've also got foam on here to help smother out fires. Some of the tools we have in the back are if there were to happen to be a car accident or something similar where we'd have to cut or raise metal. These tools are lithium-ion battery powered. Battery goes right in the back compartment here, just like most of your tools at home. A little bit different though, this could actually lift a car up if we needed it to, simply by turning this handle. Everybody's, I think, pretty familiar with the term jaws of life. This is kind of on a similar plane. These are handheld e-hydraulic tools. They could crush a car, lift a person, pretty much anything or anywhere we need to get into, this tool could perform.
Now you say e-hydraulic.
Yes, sir. It's a combination of electronics or the battery plus a hydraulic pump inside that has a small bladder. So by forcing that liquid through, we get the power of a traditional hydraulic tool in a compact package that's also very mobile.
Now what's the importance of hydraulics? Because, a hydraulic just means liquid. And why would you use a liquid in order to create pressure?
Well, just think of a garden hose. If you throw your thumb over the top, it comes out a lot faster, a lot stronger. So anytime you constrict that liquid, it immediately gets stronger. It can increase leverage, lifting pressure, pretty much anything you can think of. How a boat motor works, how a car works.
You cannot compress a liquid, so the
exactly
object
right.
is going to move before the liquid is going to collapse.
Exactly right. And the thinner or stronger you can force that through, the stronger the tool.
Now, that kind of leads into Bernoulli's principle. So when you're putting out a fire, you're starting with a large hose, and by the time you get down to the actual fire, you're probably on a smaller diameter hose?
Well, we start from 3-inch plumbing, and Bernoulli's principle actually comes into our job a little more than just the hose, believe it or not.
Okay.
But based on what you were discussing, we'd start from 3-inch plumbing and reduce it down through adapters and couplings to a 1 3/4-inch hose that then goes to an aerated nozzle. So in the entire process, we're introducing air and constricting, so we do get a little bit of friction loss, but for the most part we get a lot more pressure.
So where does the hose hook to your
one of the discharges, I can show you right here. This discharge right here is for one of our supply lines, and that would force 3 inches of water down to a reduced adapter. Now, Bernoulli's principle also comes into effect when we use our pumps to draw water in. We actually have to create a vacuum to pull water up from a static source, such as a pond or a lake, a dump tank. We can actually create our own hydrant, basically.
So if there's no hydrant available at the location, you have to pull the water from whatever source you can.
Exactly right. We would pull it from typically a 4,000-gallon tank, and these hard suction hoses on the side create a seal, and then by using an impeller, we create basically Bernoulli's principle in effect and pull the water in with negative pressure. Most important factor there would be to make sure it's airtight.
Okay. And this is where you would also connect?
This would be one of the intakes. Now, typically you wouldn't be able to use that principle on this because it does allow air in. This is an intake for a pressurized source because it allows us to bleed off air. The last thing you want in a hose line is air when you're inside and you need water. So this allows us to bleed that off and maintain a solid pressure for the water inside.
So as we go through the firehouse, we're going to find out that not all fire trucks serve the same purpose.
Absolutely
So
not.
you called this the
Pumper.
pumper, all right? So
Or engine.
Its job, or the engine, because it works like an engine. It intakes water and pumps it out, right?
Yes, sir.
So does it have a tank?
It does.
Hold water?
It has a 535-gallon resin or fiberglass tank that holds water. We also have 2 onboard tanks for foam. We can introduce that for fuel fires, fires that are burning an unknown substance that isn't going out like a typical Class A, like wood and paper.
Okay. And if you were going to a location where you knew, okay, there is no hydrants, there's no water source,
We'd use the monster behind you.
and we go to this.
Yes, sir.
So this right here is called...
That is our tanker or tender. Basically, that is a fire hydrant on wheels. It's got about 4,000 gallons of water in that large baffled tank behind you. The reason the tank is baffled is because obviously with water weighing 8 pounds per gallon roughly, when you get into the 4,000 gallon range, that can make a truck move all over the place. So strategically placed baffles throughout the tank make sure that we don't get the surge when we're driving around.
So you make a turn, the water wants to continue.
Exactly right.
That is Newton's law.
But if you break up that surface, then the truck's a lot more maneuverable.
Okay, awesome. All right, so here we have another truck. It's a little smaller. Is this truck for small fires? What is the purpose of this truck?
This truck actually replaces, 2 of these would replace one of the larger ones you see behind you. Now those vehicles are specifically designed for airport rescue firefighting, so their only job would be here on base to put out a fire if there were ever to be a plane crash. Now the technology that is advanced from that, based on 3,300 gallons of water down to 500 gallons of water, is ultra high pressure. This is why I need you guys to pay attention in science class. This truck can get there a lot faster. The hose is very maneuverable. It's easy to use. I can drive into all kinds of places, and I can kill a lot of heat just by using droplets versus dumping a large volume of water and trying to drown it. This would absorb heat, allow me to get closer, allows me to get there and help people a lot faster.
And the droplets, or the mist,
Yes.
also helps take away the oxygen.
Absolutely. It can smother it out based on it being vapor, as long as the heat's not too much to keep it from getting there.
All right.
That's the only limitation on that
So
vehicle.
the heat can eventually turn it into steam, which defeats the purpose.
Exactly right.
Okay. So what is our volunteer here holding?
Well, I was going to say this tool, and then I realized there was a person, so I didn't want to do that. The tool that she's holding is actually one of the oldest in the fire service, and it's also the most commonly used. One of the rules we tell all our new firefighters is you never get off the vehicle without a tool. Period. Doesn't matter what it is, you're going to need something when you get there, and you need to contribute. Now, this is one of the newest and most fascinating pieces of equipment we have in the inventory. They've only been out for about 2.5 to 3 years. This one has been around since the 40s. It's barely changed, but it does exactly what it needs to do. It's a multifunction tool called a Halligan, and I'm just basically going to have her rotate this slowly, and I'm going to kind of explain to you what it does. This tool is designed to give you a mechanical advantage. It's also designed to be a self-rescue tool. It's designed to be a forcible entry tool. Pretty much anything you can think of, I can do with this tool. I can puncture, I can pry, I can use the forked end to get leverage, I can puncture down through a car, I can do just about anything with this.
So one thing that I tend to focus on when we're teaching students about engineering is, one thing we ask is technology. What is technology? And the biggest answer we get is something that you plug in or some electronics. And that's not necessarily true when it comes to electronics. That is modern technology, but any tool or any...
You're doing it wrong! No, okay.
Any tool or any piece of equipment that makes our life better is technology. Like a fork. Before the fork was invented, we ate with fingers. So a fork is technology. It's old technology, just like this is old technology, and it's still the same tool and hasn't changed very much.
Not at all. This is a smaller version, which is about the only thing I would say is different, because now we can carry these in the cab safely versus having them in the back, so I can have it immediately at my disposal. What I would tell you is I've used this in itself to cut a car practically in half just by leverage. It's not sharp, and I didn't mean to grab that from you, sorry. It's not sharp by any means. There's really nothing special to it. It's simply a mechanical advantage for leverage.
All right. Nice. So this piece of equipment is a little odd. Don't see this driving around in town or have to pull over to let this go when it's coming back from the fire. So what is this piece of equipment used for?
Well, let me get to you. This large truck was actually designed for airport rescue firefighting. Basically, the principle behind it is fire burns hotter on certain materials, obviously metal and fuel. It's going to burn a lot hotter than your standard Class A fires like wood and paper. So you need a way to approach the aircraft safely and to put out as much fire as possible to allow survivors to escape. That's done through the two things that you're pointing at, the turrets on the nose and the roof. They can put out anywhere upwards of 750 to over 1,000 gallons per minute of water or foam.
So in the tank, you have a large tank on the back.
3,300 gallons, yes, sir.
And that filters through one of these two locations.
Correct.
The turn on the top or the turn in front. And these are controlled by a joystick.
They're both operated by a separate individual joysticks inside the cab by either the crew chief or the driver himself.
Okay. There are pretty large tires on here. So I would assume, based on the size and the tires, this does not move very fast.
No, we actually we can get them up to over 60 miles an hour. Unless you're going in a straight line and have plenty of room to stop, that's not the best idea. But the tires are basically designed to deal with debris and to support the weight. It is an 8-wheel drive vehicle, so they are fairly maneuverable. The length does hamper that a little bit, but surprisingly, they can get up to speed pretty quickly.
Now I see four seats inside, but 2 are recessed or put back.
Yes, sir.
What are the 4 seats do?
Well,
you have a driver.
Obviously going to have a driver's seat. The crew chief, if we have enough staffing, is going to sit on the right side. Basically, that's going to be the truck's boss. He's going to be directing the driver where to go, calling out hazards or obstacles, and basically giving the crew an idea of what they're going to be doing. The 2 seats that are recessed in the back that have the built-in SCBA cylinders are your firefighter positions. That allows them to get their gear on if there was a rapid emergency, to get their gear on in the rig, and then to hop out prepared to grab a hand line that's located underneath the nose turret, approximately 150 feet of 1 3/4 hand line for when they make entry into the aircraft.
Now, who drives? Is it the first one there? Do you fight over who's the driver?
We have assigned drivers every morning.
So you have to be certified on each truck in order to drive it.
Pretty much. Obviously, we're always studying, always going through different training courses. I'm finishing up an inspector course right now to be allowed to inspect the buildings for fire prevention. We have officer courses, and obviously all the vehicles in here have driver operator courses as well. By the end of it, each firefighter at a certain level has to be able to operate every position on every vehicle here.
So I have expressed this before. Education doesn't stop. All right, if you want to be good at your job, you always, always, always will be learning something.
Our library here is actually bigger than the one I had in college.
Okay. All right, so let's take a walk down and see what else you have in the firehouse. So why does it look like you have a shed inside the firehouse?
Well, that's actually a good question. This was a shed that some of our firefighters converted into a training building. So basically what they did was took a 1-story shed, added a 2nd story, and made it modular. So we can change it to mimic pretty much anything we run into on a house fire so that we can train for it ahead of time as best as possible.
All right, so One of the pieces of equipment that you use in this scenario when you're training, and actually you're testing and training to use it in real life, is this piece of equipment that you're holding. So what do we have here?
Yes, sir. What we have right here is a battery-powered Draeger thermal imaging camera. What it allows us to do is differentiate between heat signatures inside a building. Now, a lot of people think that we only use these to rescue people, but this actually gets pulled out on every fire we go to. It's invaluable for finding fire that likes to hide in void spaces. We talked earlier about fuel. Well, fire needs oxygen to live. Well, you're not going to find that in drywall, but you will find it in the separation between drywall and insulation. You will find it in balloon frame construction where the house has void spaces throughout. So this would actually show us where the heat is anywhere around a building or around an area. Oh, I see heat. There you go. 84 degrees.
Okay.
So basically what this would allow us to do is in an oxygen deficient environment where we're masked up, wearing SCBA, it's very difficult to hear. It's actually a lot of obstruction to your vision as well. You're typically crawling in an unfamiliar environment. This would allow us to find either people, fire, or anything hot or differentiated much quicker than if we had to do it by feel or just by searching around.
And you called it a camera.
Yes, sir.
Right? So it's basically the camera I have, other than it has different modes of recording information.
Absolutely.
And the key is you can also record. So if you need that information at a later time.
We can take video, we can search on different settings as far as looking for fire specific, thermal, outdoors. Typically when there's a lot of heat signatures outside, this can help differentiate. Now the hazmat is a very interesting setting because we a lot of times deal with hazmats by plume only, and that tells us the best way to respond, how to be upwind, how far it's drifting, time advances, pretty much invaluable information that we can get just from this one tool rather than observing for hours.
All right, so that's a pretty significant tool in your job, I can see.
Absolutely, it comes off almost every call.
I didn't know
Right.
that that's even, that's crazy. So then
This is our own fire laundromat.
So because you guys are here on a 24-hour basis, that's your work shift, is 24 hours, does that mean you have to do your own laundry here? Is that what this is?
We do. That's not what this is specifically. We have a washer and dryer upstairs in the residential portion of the firehouse. Our bunk rooms, showers, lockers, lounge, washing machines are all upstairs. This is specifically for our fire gear because anything that off-gases or byproducts of combustion are typically carcinogens or something you really don't want to get on you. We have to wash the gear the second it's used in a fire. We bring it back, alternate to our second set, and immediately put our gear into I like words, an extractor to pull some of that junk out. Now, in order to have that gear thoroughly dried and operational, we would set it on these dryers, and what this is intense forced air. Now you see it's got weird little hooks and prongs. These would be for your gloves. Fire gloves are extremely hard to get on once they're wet, but they are extremely protective and reliable, so we want to make sure they get dry, they don't shrink. This would be where you hang your coat, suspenders, pants, and then boots could be set just about anywhere, either up on top or down low. This gets sealed, and it heats it extremely quickly and dries the gear thoroughly.
Okay, so it looks like a washing machine that you find in your community. However,
a little bit different.
Extra equipment on it. So the technology just doesn't go into firefighting, it goes into protecting your equipment.
Absolutely.
So what is this equipment?
This is our in-station or cascade fill system. So basically all your SCBA cylinders, once you get back, they're empty. We need to get them back to full as soon as possible so we can staff the rigs and all the packs.
So when we talked about SCBA earlier, we said, it's just like scuba minus the underwater. This is the tank that holds your compressed air.
Yes, sir.
One misconception that a lot of people think is it's compressed oxygen. It is not. It's
No.
compressed air.
Oxygen will blow up.
Yes.
Highly flammable.
Same thing we're breathing now, but it's compressed. And now I am a certified scuba diver, and our tanks are compressed up to a max of 3,200 PSI.
Well, because we don't have to deal with nitrogen, it's just compressed air, we can get these to 4,500.
4,500.
Now, there's a misconception that that means you can do 45 minutes of work. Not true. We just did a air conservation and physical training drill about 2 weeks ago. And I set up a station, it's about 5 stations of very, very taxing exercises. And they
So-
had to run through. Basically, you can do about 15 minutes of consistent, fully exertion type work before you need to think about, how am I getting out? Do I have enough air to get out safely? And can I get out, change out a bottle, and come back in?
So one connection between scuba diving and firefighting is, using the tank, and the exertion, or how much physical activity you do.
Conservation is key, absolutely.
Makes the difference in how long that air lasts.
Conservation is absolute key. One of the first things we teach oncoming firefighters is breathing control. And basically, you'll typically never see a firefighter running unless a life depends on it. We typically move with a purpose, but we conserve as much air as possible so that when we get inside, we're focused and can do more work.
And another key factor in your air conservation is when you're half a tank, you turn back.
Not necessarily half a tank, but that's when you need to start thinking about it and taking it seriously.
You need to take
Absolutely.
your plan.
On the pack, you have a personal safety device that'll let everybody know if you stop moving, but it'll also tell you what your air is in relation to what's in your tank. You make sure in the morning the gauges match up. When you get down to about 15 to 20, that's about time you need to start thinking about heading outside and switching out with another crew.
Now, when you said this device allows others to know when you stop moving, how does it alert them?
The PASS device will let out an audible chirping. It's a very loud buzz. I don't know that this one's in service right now, so I apologize if it doesn't set off.
Now, the audible chirping is because if you're in a smoke-filled room, you can't really see, you just follow the sound.
Right, these are reflective and they are lit as well, so that's some assistance, but there's the noise you're gonna hear.
So that is not a noise you want to hear.
No, that'll get progressively louder, and you'll see a lot of times, if you ever see firemen around a fire scene after it's done or in between activities, you'll see them kind of bounce or you'll see them lift that. That's a motion sensor to make sure that that audible device doesn't activate.
All right. So one big question from a lot of our viewers and myself is, what is the biggest difference between working in a firehouse or for a fire company on base in the military and working for a fire company outside of the base, like a volunteer, local, or city fire department?
Well, the first thing I would say are the outfits. Obviously, we get lovely attire to wear on base. We do have to conform to military standard. We do have to go through Air Force certification programs. Now, I only work here as a fireman, but this guy volunteers in his community as well as is a paid member of the Berkeley County Fire Department, where we serve as a mutual aid department. So I'll let him answer that.
So what location do you work at?
Inwood, West Virginia,
Okay.
Company 20.
Company 20. So what is the biggest difference you can tell us between your job here and your job there?
I'd probably say like rules and regulations when it comes down to it, and different structures and the way things operate. You have military standard, civilian standard, and also working on this base, your number one job is this base. You're more aircraft, more technical things you have to deal with, different types of buildings, more protection systems,
Training requirements, probably.
training requirements is huge.
How about the equipment? I mean, you're on the military base, and of course, you have these large C-17s that you have to protect. So you're top of the line equipment. What about the equipment at your location?
It's definitely more spec'd out to the standards of what the firemen want. As per the military, it's what the branch wants. The Marine Corps, the Air Force, whatever branch you're a part of, they spec it out, they choose it for you. So you don't really get much of a decision, which is a downfall, but a plus. Kind of just take it with what it is.
Okay. Now, are there any other firefighters here on base that work in your company?
Yes, sir. About 8, I believe.
Yeah.
I'd say so.
Now, did
I'd
you
say-
become a military firefighter first, or did you start out at a young age wanting to be a firefighter?
Started out young, I was 16, and then just fell in love with it ever since.
All right, and then joined the military and
sir.
became a firefighter. Do you work along with Steve Redding?
I do.
You do? I know Steve Redding.
Yeah, very close friend of mine
Give a
now.
shout out to Steve Redding.
Good fireman.
All right, yes. And a lot of other things. He's got a lot of
Sure.
things. So, all right, so let me.
That was excellent. Well done. Seriously, for off the cuff, that was solid.
All right, so we want to thank these guys, Eric, for showing us what they do in their job and the technology and the science involved in firefighting. All right, and keep an eye out for Thursdays, and we will try to get you some more STEM in our communities. Until then, let's say goodbye.
We like cash and food.
All right.